Hello, welcome back. So let's start with the third part of our end-to-end series. In this part, we will be covering exception handling mechanism in our REST API. We will be implementing a mechanism to avoid placing try and catch everywhere in our code to keep it clean. We will use Docker Compose, a tool for defining and running multi-container Docker applications. And it uses YAML configuration file to configure application services, networks, and volumes, allowing us to manage the entire stack with a single Docker Compose command. This simplifies the development and testing process. The next thing is that we will be actually pulling in the images using Docker Compose, and these images will be Loki, Grafana, Prometheus, and Redis. We will be using all of these four services in our part 3. Loki is a logging service that will allow us to log our errors and other information. Grafana is a UI tool that allows us to build dashboards for monitoring infrastructure, logs, and time series data, and numerous other things. Prometheus will allow us to monitor our infrastructure or machine that is running our REST API. Redis is in-memory key-value NoSQL database. We will be using it to store authentication-related data and caching responses. We will be implementing JWT token authentication strategy using Passport.js, which is one of the very popular Node modules. And then we will be using Zord module to validate inputs that are coming in our request before we push them to our database. For security, we will be using CORS and rate limiting. We will be implementing cross-origin requests and whitelisting some domains that can access our REST API endpoints. And for that purpose, we will import CORS module and pulling in rate limiting module as well. That this will allow us to avoid distributed denial of service attacks by limiting the number of times our endpoints can be called in specific period of time. So let's get started. Let's start with exception handling mechanism. Here you can see in app.ts that I have added a line here, app.use exception handler. It is a middleware that I created for this purpose and imported that middleware on the top here. So let's look at the implementation. If we go to presentation and then middleware error handling, I've placed 5 different files here that allow me to globally handle different exceptions that happen at different places in my code base. What I have done here is to extend my error class and implemented an extended error class that contains some extra properties that help me to handle exceptions in a better way and provide extra information about those errors. Like, for example, we are storing the original message that comes with the original exception, and we can also store a user-friendly message as a message string here, and then we can store the status code and type of error and timestamp. Timestamp allows us to identify that when this error happens, and it helps us logging these errors in Loki as well when we will be using Loki. If we go to HTTP status code enumeration, it helps us to define different status codes that we can use inside our application. And most of them are standard HTTP codes like OK, created, deleted, forbidden, and they will be sent back with our response. Now let's have a look at our HTTP status messages.ts. It is the place where we can store different messages related to our status codes. For example, for OK, we are defining the request has succeeded, and for created, we have defined the request has been fulfilled and resulted in a new resource being created. So we can define many messages here that can be used all across code base whenever we need them. Now, there is another enumeration that error types that help us to identify the type of error, whether it is an application error or it's a domain error or a system error. System errors happen, for example, DB connection failed or there is some other database error. Domain error could be something like validation error, and similarly we can have other application errors. So if we go to error handler.ts, this is the middleware we are implementing, and in this middleware class we have 4 important sections. First part of this middleware method, we are defining few variables that we will be using to log and prepare request. We will be dealing with two different type of exceptions here in this code. One is our standard error exception and other is extended error. In the code below here, we are firstly identifying whether we are dealing with a regular standard error class object or we are dealing with extended error object as a result of exception somewhere in our application. And then if it is a custom error, then in that case, we will be dealing with the extra variables that we are storing inside extended error, and we will be extracting them to our local variables. Like we will be extracting status code, type of error, application domain or system error, message that will be a user-friendly message. We may like to send it or log it with Loki, and origin message that will be the original message that happened when application found this exception. And then there is a stack trace that will help us resolving the error. And in the else part, we will be dealing with the standard error that has less number of variables, like status code. We will be putting in internal server error that because we are unable to identify that whether it was an application or other type of error. And then message. In the last part, we are using logger, which is actually Loki client instance, to log this information to Loki service, but we will be discussing it later on, that how it is built and how it is working. For the time being, we just know we have a logger available. We have imported the logger in top of this file from our logger.ts, and then we are just calling error method to log. And finally, we will be sending out our response that will be presented to our endpoint user. So this is exception handling mechanism with the error handler.ts as a global handler that we are using as a middleware to catch all our exceptions and handling them properly and gracefully. So it is time to start configuring our infrastructure that is required for part 3. During part 1, we covered that how we can containerize our Node.js application. Now we need more infrastructure and services to run part 3, and for that purpose we will be using Docker Compose file. Docker Compose is a tool for defining and running multi-container Docker applications with ease. It uses YAML configuration file just like Docker file to configure application services, networks, and volumes, allowing us to manage the entire stack with a single command. So if we have a deep look into the Docker Compose, we can see that we have a services at the top and it defines number of different services in YAML format. And each service is labeled like it is Redis service, Loki, Prometheus, Prometheus, and Grafana. We will be using 4 of these services. We will not be using Prometheus at the moment. In Redis, we are defining the image that we can use like Redis latest. It is telling that you find the Redis latest image from Docker repository and pull it, and then providing the container name. When we run this image, and what will be the name of that container on our machine. So we'll be running it in name Redis, and then the port mapping is there that defines that Docker container internal port 63079 will be mapped to host machine 63079 port. After that, we have networks. Networks in Docker Compose is a logical way to define a virtual network for all of the containers to communicate with each other. So Loki is there, Grafana slash Loki, and I'm pulling version 3.2.0. It will be running in container Loki on port 3100, which is default port inside the container port 3100 on the local host. Then if we have a look at that, we know that the containers are non-persistent or they don't maintain their states. And if we actually stop the container or delete the container, in that case, there will be no information available to us if it is stored inside the container. Volumes allow us to map our local host machine containers to map containers internal directories to one of the host machine directories, or there is another way that we can also map them to Docker volumes that will be maintained by our Docker desktop or the Docker ecosystem. In this particular case, we will be mapping our internal container port to our host machine. Then we have a command option here that will allow us to use a configuration file that resides on our local machine that is inside our directory, like here, which will be mounted to internal container Loki configuration file.yaml. And then we have the container name, network name here. And in case of Prometheus, that we use for infrastructure monitoring like CPU usage, memory usage, and other parameters. In this case, we will also be mapping this particular /prometheus.yaml, which is inside our current folder, to a location /etc prometheus /prometheus.yaml that is a location inside our container. So our container application will be able to find this configuration that is stored outside the container. And if you go to Grafana, we are not using local host storage, but we are providing a Docker volume in this case, Grafana storage, and we are mapping that to variable /lib/Grafana inside the container. And finally, we have defined our network, my network, and our driver will be the bridge driver. So this is the configuration that we need to run Docker Compose command. When we execute command Docker Compose up -t, it will pull all the images from Docker's repository, and then it will start containers for us, map the volumes, and put them inside a common virtual network so that they can communicate with each other. So let's try to run this command and see how it works. So let's have a look at configuration files. Let's start with the Loki configuration. It is also following the YAML format. If we go to the top, we can see that basic configuration defines the port numbers. Loki server runs at 3100 port. For gRPC, I'm providing 9095. gRPC is a binary protocol for remote procedure call, which is generally used for microservices communication, and when the microservices are hosted in their own containers, other things like interface names. And then we have the instance address. In my case, it will be running locally within Docker container. So inside Docker container, it will be 127.0.0.1. And then there is a path prefix, a variable Loki. Loki will be using a folder inside my project, and that will be variable Loki for Loki, and I'll be storing information that is generated on runtime here. This kv store in the ring, and we are trying to store key value pair information in memory, which is not recommended. If you are in production, you can use etcd or console for that purpose. In case of ingester, we are also storing the information in a NoSQL format and in memory. Schema configuration. If we have a look at schema configuration, we have to specify the date from when we will start logging in the information. Then we have store name, and then the schema version. it is important that you should follow the exact schema version that is compatible to the image version that you are pulling from the Docker's hub. It is indicating that any index file you are creating will be prefixed with the index underscore score, and the duration after which the indices will be updated is 24 hours. This Loki file will be mapped to a directory inside the container so we can start the Loki instance. If we go to the Prometheus, which we will be using to monitor our CPU usage and memory and other infrastructure related, is telling that we will be collecting information every 15 seconds about our host, and then there is a job name which will be important to identify the instance, and in our case we are naming it API, and then we are targeting a particular machine like 192.168.56.1 in my case, and our API is running on port 3000. So we'll be collecting information from this particular target. It is time to call docker compose up -t, and we are executing this from within our folder that contains docker-compose.yml. So in case your file name is different from the conventional file name, you can provide that file name inside this command as well. So it is pulling Grafana, Redis, Loki, Prometheus, Promptail. Promptail I'm pulling, but I'm not using at the moment. It will take some time. Now we are creating containers. Now let's have a look at Docker desktop, and here we can identify that we have Grafana, Prometheus, Promptail, Redis, and Loki images that we pulled from Docker Hub. And if we go to the containers, we can identify that we are running container with name of Redis, Loki, Grafana, Promptail, and Prometheus. We can see that we have these URLs available with us, and if you like to test if the Loki is working, just click it and you can see that I can type ready here, and if it says ready, it means it's working. Now if we click Grafana, I can type admin here, and then I can say test 1 2 3. Just I change the regular admin for this container. Here we are on Grafana, and we can add dashboards, we can configure connections here. I've tried few, but you can add a lot of different sources of data for your dashboards, and you can connect it with Loki and Prometheus as well. So you can monitor pretty much all the major servers and services that are available today. Let's get back to Docker, and if we click Prometheus here, we can see that Prometheus is also working. We will be exploring these tools in detail later while testing our application. In the real world uh, or the production environment, we use other tools like Kubernetes and Helm and Ansible for deployment. But Docker Compose is serving our purpose at the moment. We can always stop our containers with just one command, docker compose down. This will remove, this will stop and remove containers. And whenever we like to start them again, we can run docker compose up -t for detached. And I've installed a plugin here for Docker that can also show me my running containers here, and it is pretty handy. It is time to connect our Loki service with our REST API. What I'm doing here is I've created a logging folder under infrastructure, and then I've created a couple of files here like logger.ts and request logger.ts. Logger.ts provide us the code to connect, and for that purpose I need Winson module which I npm installed, and then I need Loki transport which I npm installed again. Then I'm trying to create a logger instance by calling the instance logger and providing the required parameters. The major parameter that I need here is transports, and I'm providing two different transports for logging. One is to show my logs on the console, and I'm creating a new transport.console here. Below that, I'm creating a Loki transport, and I'm also mentioning URL. I can place this URL in .env file later on, and the right place for it is .env file, and then I can always get it from the environment variables. If I look at the tables, job backend client ts underscore p2, in this case, I'm trying to assign a tag which will be used in Grafana to identify the stream of data that is coming in through Loki. Let's move to the next file, and this next file will help us log all our endpoint requests that are coming from the client. In our case, we are using Postman for the time being, or it can come from any mobile application or web application or some other sources. So this middleware will be used for logging those requests. And here what we are trying to do is to use the same logger. We are saying that do not include anything that end up with metrics, helping us to avoid logging any Prometheus related endpoints. We have logger.info, and in logger.info we have HTTP request, and we're logging in entire information here. Now let's look at app.ts and see how we are using Loki logger here. We are using the middleware we just created, app.use log request. We have environment variable in Loki underscore enabled. We can always disable it by setting it false. So if the Loki enabled is equal to true, we can always log our HTTP request using this middleware we created in request logger.ts. Visited errorhandler.ts, and we are revisiting it again just to have a look at logger.error. So here we are trying to use the same logger Winson instance that we created, and we are trying to log our exceptions. Now it is time to create Prometheus middleware, and I've created a folder named monitoring under middleware and under presentation. So here I have prometheus.ts. Now it is time to configure our application and write some code for getting matrices from our NodeJS REST API application. And I have added a file under presentation monitoring prometheus.ts. I'm npm installing prom client, and I'm also importing request response next function from Express. In the next step, I am creating a register that is a key to contain all the matrices we like to collect from our application. And here we are saying register is equal to new client dot registry. That will give us the object of a registry. And after that, we are calling client collect default matrices and passing in the register. This is a method from client that will allow us to add all the default matrices for Node.js. And in the next step, we are trying to create one custom metric as an example that will help us to calculate the time or duration for HTTP request in seconds. But to do it, we also need some other middleware. The first thing we are going to do is register the custom metric, register.register metric. We are passing in HTTP request duration microseconds. We are creating a middleware that will help us collecting duration in microseconds for a particular HTTP request. by starting the timer and doing the calculation work. We will be using this middleware function in our app.ts, and finally we are writing a method that we will use with our slash matrix endpoint to collect the matrices. And we are exporting both the middleware and the endpoint matrix. If we go to app.ts, if you go to app.ts, we can see that we have added app.get, and it has a route slash matrix, and then we have matrix endpoint. And we can also notice that we have added a matrix middleware for collecting information about our custom matrix HTTP time for individual requests. So let's start our server here. Now I like to test Prometheus, Grafana, and Loki. For that purpose, I'm going to Prometheus first. And in this screen, I can select different matrices to view. If I select HTTP request duration seconds count and execute it, I can see that I have this route slash matrix that is called once. Let me try to call get user by ID 1, 2, 3 times, and I'm getting back to my Grafana. Uh, I'm getting back to my Prometheus screen, and here I'm executing it again. And now you can see that uh, during the time slash matrix endpoint has been called thrice for each of endpoint calls, and the route slash API slash user slash ID, it has been called thrice. So we have started collecting data through Prometheus. Have a look at different matrices here by selecting them. If I select another one here, that one is the custom one, HTTP request duration seconds bucket. And let's see how the data looks like. It is here, and we have the histogram data here, 1.5 to 5 that we were posting. Now I'm visiting Grafana website, and here I can see a number of dashboards available for us. They can help us monitoring different data sources in real time. So I'm searching Loki here, and for Loki I can see that I have many pre-built dashboards available here. I can download any of them. Then I can download the JSON file for this dashboard, and I can use it or upload it to my Grafana instance. Similarly, if I go for NodeJS, if I go for NodeJS search here, I can find number of dashboards here. Maybe this one, or I can download the JSON file. Now let's go to Grafana. I will be adding data sources and dashboards. I can go to data sources and I can select a data source like Prometheus, and here I can provide it is the container name, port number, and then save and test, and it connected. Now if I go to add another collect connection, I can pick Loki here, and it is connected. And in connections and data sources, I can see I have two different data sources configured with Grafana. One data source is Loki and the other one is Prometheus. I have downloaded few Grafana desktops and now I like to import them. Now I can see the live data related to CPU usage, event lag, heap size, external memory, process memory, and availability. And it is also showing me that I'm using Node version 22.9.0 and I started my REST API instance 42 minutes ago. Adding another one. This one is showing my Loki logs, and if I call get all users once or twice and refresh, then I can see that I have that log here. I don't have any exception at the moment, so there is no exception data.